Okay, today I will show you how to make a cluster analysis by using K-mean clustering. So the purpose of this cluster analysis is to make a climate zone for Peninsula Malaysia. So this is some tutorial that I will prepare to make cluster analysis by using K-mean clustering for we want to make a climate zone for Peninsula Malaysia. First, we must have our data. We have our data by using Excel here. We have four data: rainfall data, minimum temperature data, average temperature data, and max temperature data. So, for example, here I open the rainfall data. So I show you the arrangement of the rainfall data here is it's like this. It's not like this actually. Uh, let's see. This one. So the data that we need is annual data set. Annual data. So you take the mean annual data for each grid point from the ERA dataset. So you have for this is from ERA 5 dataset. I have rainfall, average temperature, minimum temperature, and maximum temperature. So this is all the average temperature for each grid point from 1950 to 2020. So for grid point in Peninsula Malaysia, I have 1091 grid point in Peninsula Malaysia. So all data has been extracted for monthly, and then I sum it for rainfall to get the average for 1950 to 2018. So you get the annual one for each grid point. So this one is all annual, average annual for each grid point. So we have let and long here. So prepare your data like this. You have the grid point, let, uh, long, latitude, longitude, rainfall, temperature, average, minimum temperature average, and maximum temperature average. So you have four variable here to make a cluster analysis. So from this four variable, now we open our R. So this is our code for cluster analysis. First, you must have install your library Rattle, your library cluster, FPC, and Factor Extra. So how to install this library? You must right here at the console, at the R console here, right here, install packages. So if you want to install Rattle, just copy here and then uh, write it like this. After that, enter. Oh, so I have already installed my package, so it will uh, already installed. So make sure you connected to the internet when you try to install all this package. So I have already installed, so it will not be installed anymore. But if you want to install the package, you must use install package for each of these library, Rattle, Cluster, FPC, and Victoria. And then we open our data just now. So set working directory, get your address, folder address. So my folder address is here. Just copy here your folder address up here. Just left click and then copy this one, put it in here between the apostrophe and then paste. Make sure each of these have two bar like this, two bar, and then you can run the line. Yeah, you see it's run properly, no error, so it's good. So and then you read the claim data set just now, which is this is the data set that I show you just now. This data set which all the variable annual one for cluster analysis, rainfall, average temperature, minimum temperature, and maximum temperature. Arrange is everything like this, and then you copy the name of this data set, put it here, claim GIS. So we read this data set. claim GIS. And then we want to read only the variable, which is here. The variable is rain until max temperature here. So we have 1, 2, 3, 4. Fourth column, 5, 6, 7 until 7 column. So we read 4, put it here, 4 to 7. 4 to 7 column. Okay. Now we read the dataset, run line selection up here, run it. So no problem. Run it again. So it read the data. And then we read only the variable. And then we look at the data. See, we have the data here. Rain, temperature, average temperature, minimum temperature, and maximum temperature. So we already read all these variable from each grid point. 1091 grid point for Peninsula Malaysia. Now we scale the parameter. For cluster analysis, we must scale it first. So you use this code. I will put it in this code. I will put in the description later on. You can check that one. Or scale the data set. Scale this clean data. And then read it. And then after we scale it, we can see that all the data has been scaled for each of the variable. For each grid point. So after we scale it, we run this one. Just follow the follow this code that I provide down here. It will give you a lot of information on the value of this k-mean. It will give you what is the cluster mean, everything, something like that. And then if you want to investigate the number of cluster that you need, you can check it here. For 1 to 4, how much, what is uh, the statistic? All the statistic will be given. So we can plot it like this. This is the cluster. You can check here by using between sum square or total sum square, which is the break that you can select how much cluster that you can use for climate zone. But this is only one of the method. But later on, I will show you there is another method like the index, everything, something like that. But usually I will use the index. Easy for you to decide which cluster is the best for cluster analysis here. So here is a bit user kind of experience to visualize and decide. It's not automatic. And then we can also plot it here for this one. You can have a lot of plotting. You can see the how the cluster has been formed for 4 cluster by using this variable to for climate zone. After that, we start by using k-mean clustering down here. This code also I will put in the description. So if we want to make a 4 climate zone, we just change number 5 here to number 4. So k-mean clustering, it will do a 4 clustering and then run it. And then if you want to check the attributes, you can check the attributes here. What do you want to check? Something like that. You can check all the information that you want. Okay, you want to check the size. This is the size of each of the cluster that you form. So if you want to create a 4 cluster just now from 1091 grid point, so it will form this 4 cluster. Or some cluster is very big, contain 545 grid point, and another one, the smallest is 107. And then that is the size of the cluster. Then you can check all the cluster. It will give you the information on the cluster. Which grid is what cluster, which grid is what cluster, something like that. Later on, I will show you. It will all will be in the Excel file, and then we bind the cluster. This is the cluster that I bind it. I bind this cluster just now so that it will in one list, and then I bind it with the let long data set in the data that I put up here just now. We have a let long data set from ClimGIS, this one, that long. So I bind it. So it will bind this one with the result of the cluster. So now we continue. After we bind it, you see, this is all the result. I bind all the result for the cluster just now here. So let long, it will give you uh, each grid point is which cluster, something like that. Now, this is the structure of fit object. This is some statistic that if you want to check later on, you can check all the statistic here. What is the size of the cluster? This is all the information for the statistic that you run for Kemin cluster. And then you can make a class plot by using this this code. This is the class plot. So each grid point belong to which cluster, something like that. So you can visualize it to the representation of Kemin cluster. It's like this, and you can see it easily. So as you can see here, all the cluster is separate very well, but some cluster in the middle here cannot be separate very well. It's overlapped with other cluster, something like that. But a lot of other cluster is very well far away from it's from its own cluster for four cluster. And then centroid plot, I don't know if we require this one centroid plot also. No, it's error. No need to use this centroid plot. This we have plot cluster. This is another way. This is the centroid plot for of K-mean. This is another way to visualize our data. You can see cluster 1, cluster 2, cluster 3, and cluster 4. It form its own cluster. After that, this is the statistic also. Cluster stats. When you write the paper, you need all this information to tell how much distance of each cluster, something like that. If you want to check that one, cluster size, number of cluster, number of grid point, minimum size of the cluster, and then you see the average distance of the cluster. It's all given here. Median distance, Parisian, all the statistic here, you can use it to understand the cluster that you run just now for this analysis. And then you just write all the data set here, write it here, and then you will get your result. This result is for, oh, this is for 4 cluster just now. I should, this is for 4 cluster. You write it properly here. This is for 4 cluster. So this is for 4 cluster. So the name is cluster era 5 came in 4. Cluster era 5 class came in 4. This one. This one. Not Excel. We remove this Excel. This one. This is all the result that we have just now. We have let long and see bind it with the result of the cluster. So each grid point here, it will give the cluster here. That is the result that we get. Now we visualize that data set into ArcGIS. So we open ArcGIS. So this is ArcGIS that I made just now for all the other cluster analysis, but I will redo it so that you can learn from it how exactly I did this mapping the cluster into the ArcGIS. So make sure that you have the map of Peninsula Malaysia, the whole Peninsula Malaysia here. Make sure you have this map. You can just easily download it. So I just remove everything that we don't need here. And then we can add the data. The data that we prepare just now is era 5, what D4. So we prepare era 5, what D4, add. This one. Let's see. So I just add what D4 just now. Era 5 what D4, and then you right click it here, display XY data, and then make sure the first X field is LED. and the second Y field is longitude, and Z field just leave it as none, and then you click OK, and then OK again. You see all the grid point have been mapped uh, in the Peninsula Malaysia map here. So this result will be open here. So after you put the grid point just now, right click, go to the properties. After go to properties, go to quantities. After go to quantities, you use value here in the field here. Go to the value, and then go to what the class, the name of the result just now, what the class. After you go to what the class, go to symbol, go to properties for all symbol, use a square bracket like this, edit symbol here. We want to remove the boundary, edit symbol, then there is no color. Okay, so there will be no line here because it will interference with your how to you visualize the data. So remove the border for this polygon, and then click OK, and then you see it is still green again, and then you change, put it color again, color ram here, you put it again. Is this one? This one. I like this one. Is give us separation of color is very well. After you put the color ram and then apply, and then okay. Okay, now you see this is actually k-mean k-mean clustering by using four cluster. So this is the climate zone of Peninsula Malaysia by using Era 5. I put Era 5 here. Era 5 graded dataset by using k-mean clustering. So this is the climate zone based on the four variable: rainfall, average temperature, minimum temperature, and maximum temperature. So later on you can change you can make another cluster, maybe for 3 cluster or 5 cluster. For example, in the dataset just now, I put all the something like this. Uh, in the code I put here just a note here, k value 4 here means 4 climate zone. If you want to do a 3 climate zone, you can just change the value here to 3, something like that. And then you must change here also the name of this is also 3. Make sure you change the name, change the value of cluster that you want accordingly here for KMF if you want 4 cluster. But if you want 5 cluster, you put 5 cluster. And then you rename your output accordingly for 4 cluster, 5 cluster. Okay, I think that's all for this tutorial on how to make cluster analysis for climate zone. This is for example of Peninsula Malaysia by using ERA 5 graded dataset. So I will put this code in the description. If you have any question, just put it in the comment. Okay, thank you for watching.